Okay, section 2.5, problem number 26 is kind of a doozy. Limit as x approaches 0 from the right of this whole mess right here, 1 over the square root of x minus 1 over the square root of x squared plus x. Okay, first thing you should always think about is plug and chug, but sure enough, doesn't work right there. We end up with a 1 over 0, which is undefined, and you also get a 0 when you plug 0 in right here. So kind of a double whammy. So direct substitution isn't going to work. Okay, the first thing I noticed right here is that we've got two different fractions that are being subtracted. And there are things you're able to do with fractions to clean them up when you have just one fraction, but having two is kind of a pain. So my first goal is to try to combine these two fractions into one. Now to do that, when we're subtracting two fractions, we're going to need a common denominator. And we're actually closer to that than you guys might think here. What I'm going to do, and I tell you what, I'm just going to cram this in red right here, is I'm going to work on rewriting this second denominator just a little bit. What you might notice is that both of those two terms contain an x. So we could rewrite this as x, if we factor it out, times the binomial of x minus 1. And now, let me just refresh everybody on something you guys learned a long time ago, but you might very well have forgotten. If you have, everybody, the square root of a product, such as a times b, that can be broken up into the square root of a multiplied by the square root of b. This is the whole concept behind simplifying radicals, everybody, where if you go to take the square root of a number like, oh, I don't know, 72, that's not a perfect square, you can split that 72 up into 36 times 2, and then, here's the step I was just talking about, you can break this up into the square root of 36 times the square root of 2. You can evaluate the square root of 36, which is 6, and then just leave the root 2 there. And that is the simplified form of the square root of 72. So this concept right here is one that we forget sometimes, but it's absolutely necessary to doing this problem. So I'm now on the next line going to make this denominator the square root of x multiplied by the square root of x minus 1. So forget that and forget that. Well, it's like a triple decker right here. That bottom line I have in red is my new denominator in the second fraction. And now you might realize that the first factor right there in that denominator is the same factor in the first denominator. Okay, so all I need to do to get a common denominator now is multiply the first fraction by the square root of x minus 1 over itself. That actually wasn't as bad as I thought it was going to be. So where are we now here, guys? This now gets rewritten as the limit as x approaches 0 from the right of, all right, well, this first numerator is just going to become that. That's just the square root of x minus 1. We had a minus in the middle of all that, and then the second denominator isn't changing at all. That's just a 1 all over our common denominator now, which is the square root of x multiplied by the square root of x minus 1. So that was a little bit messy, and it's still a mess now, but we did accomplish one goal. We got the overall function from two fractions being subtracted down into one big fraction. Now, plug and chug still doesn't work for the same reason. When you put a 0 right in here, now you end up with 0. Although notice, we no longer have that problem right here. This guy is the problematic factor in the denominator that we're going to have to work on. So we're still not there, and there's still some tough work to do, but I think we're making some progress. Okay, the goal here, I think, guys, is to try to get that square root of x in the denominator to cancel out. Here's how we're going to do that. What we have in our numerator right now is a binomial. We're going to multiply both the top and the bottom of this fraction by the conjugate of that binomial in the numerator. And that conjugate would be the square root of x minus 1, but instead of a minus 1 at the end, it's going to be a plus 1 now. And of course, we have to do the exact same thing down in the denominator. Okay, so let me put that blue parenthesis back there. Okay, now what does that accomplish for us? All right, let's see. This is going to become now the limit as x approaches 0 from the right of, all right, guys, and in that numerator, we're multiplying two conjugate binomials. So our first product is going to be this term right here times this term right here, and maybe you can see that. That is just going to become an x minus 1. When you go to do your outer, which would be this, and your inner products, every time you do this, when you're multiplying two conjugate binomials, the outer and the inner products always cancel out. And then it's just a matter of your last products. negative 1 times positive 1 is going to get us a minus 1 at the end of all that. I just realized I goofed something up here, guys. Nobody yelled at me. That should have been an x plus 1 right there because of that plus sign right there. Duh, Mr. Fontana. But luckily, that's pretty easy to fix. So that should have been, let's see here, guys, an x plus 1 right there, which would have made, let's see, I goofed it up here too. That would have been an x plus 1, and that would have been an x plus 1. That would have been an x plus 1, and that would have been an x plus 1. Oop, and so would that. Okay, I'm much happier now. Here's why. Because this now becomes x plus 1 and then a minus 1 at the end of all that. That's what I was expecting to see. Now, on my next step, this plus 1 and minus 1 are going to cancel each other out. Whew, I got worried there for a second. Now, the denominator here is still a disaster. Okay, I'm going to leave that, though, as the square root of x multiplied by the square root of, get it right, Fontana, x plus 1. And then that gets multiplied by this binomial here, the square root of x plus 1, and then a plus 1 at the end of all that. So, that is a mess. Now, are we getting closer to the answer? Yes, we are. The plus 1 and the minus 1 cancel, just leaving us with the x here on top. Now, if you think back to where we were a few minutes ago, the problem here all along was this square root of x in the denominator. If you were to put a 0 in there for x, that's what gives you 0 in the denominator. And we were really hoping that that square root of x in the denominator would now cancel with something in the numerator. It doesn't really look like it does, but actually, guys, there is progress to be made right here. So let me pull you aside for just a second and remind you of something you guys learned a long time ago. If I gave you something like x to the 11th power and asked you to divide that by x to the 7th, every single one of you is going to tell me without batting an eye that the answer is x to the 4th. And you're right about that. But let's think about what you just did. You took a division problem here with two monomials and you subtracted your exponents. X to the 11th divided by x to the 7th, well, all you do is you take the 11 minus the 7 and you end up with x to the 4th. Now that probably doesn't look relevant to what I just put a box around right here, but here's why it is. If you take a look at our numerator, guys, that's x. And the part of the denominator I care about is the square root of x. So let's talk about that. X over the square root of x. Does that simplify? Yes, for the same reason that this one did right here. That numerator is x to the 1st, and the denominator, is x to the 1/2 power. So if you do the same method you did to get this answer right here, your answer is going to be x, and you take your numerator exponent minus your denominator exponent, and we end up with an x to the 1/2 as that quotient. So it didn't look like they cancel out, but in actuality they do. So let me shrink this down, everybody, and get a little line going right here, and then I can zoom in a little better on what we need. Okay, let's go get them, guys. This now becomes, we're actually close to being done here, the limit as x approaches 0 from the right of, okay, big parenthesis and big fraction bar. So the x divided by the square root of x gave us an x to the 1/2, or I'm just going to rewrite that as a square root of x. That's all you get in your numerator now, guys, but that took care of this and this. Everything else in the denominator is going to stay because I think that's okay when we actually substitute 0 in for x. So we have the square root of x plus 1 times in parentheses another square root of x plus 1 at the end of all that. And I know it's still messy, but it looks like plug and chug is going to work now. Let's try it. Up in the numerator, the square root of 0 is, of course, 0. Down in the denominator, the square root of 0 plus 1, that becomes the square root of 1, which is just 1. And then in parentheses here, well, again, the square root of 0 plus 1 is the square root of 1, which is 1, and a plus 1 that was there already. So that's going to get us a 0 over 1 times 2 is going to be 2, and we end up with our final answer here of 0. So again, I hate when we do all this work on a a problem like this and we just end up with 0 for the answer, but sure enough, guys, that's the way that this one pans out. So that is how you handle problem number 26. Definitely one of the harder problems in this section. So not one you should beat yourself up for if you didn't get that one on your own, but hopefully now you understand where that solution came from, and if you see something like that moving forward, you'll have a better sense for how to handle it next time.